Hi all, welcome to i-tutor Academy. Today we will discuss Unit 6 of mmpc 009, that is Planning and Control for Batch Production. And the objectives of this unit are: after completion of this unit, you should be able to understand the nature of batch production and the circumstances under which it is used, appreciate that batch size determination, sequencing and scheduling are the major problems in batch production, and determine the optimum batch size for single and multi-product case produced on single machine, and appreciate the problem of aggregate production planning and master schedule determination, get an idea of material requirements planning and its function in an organization, become familiar with the line of balance as a valuable tool for monitoring and control in batch production, and become aware of new developments like kanban and flexible manufacturing system. Structure of this unit are: there is an introduction, features of batch production, how to determine the optimum batch size, aggregate production planning, material requirement planning, the line of balance, that is LOB, for production control and monitoring, problems and prospect of batch production, summary, keyword section, and self-assessment exercises also there. And introduction: when a variety of product is to be made and the volume of production are not large enough to justify a separate line for each product, production in batches is often resorted to. Batch production implies that general purpose machines are utilized for the production of different products. Material flow tends to be more complex in such system than in mass production system, and the layout plan for such a system has to be carefully designed, keeping in mind the diversity of products and their individual flow patterns and production volumes. Naturally, in such system the production time are larger as compared to those in mass production. Batch production is distinguished from the job shop as follows: and in batch production, a continuous demand for certain products exists, but because the rate of production exceeds the rate of demand, and there is need to produce product in batches. The scheduling problem here is concerned with determining the batch size of for products and the order in which they should be produced. And in job production, a stream of orders has to be processed on common facilities or production centers, each job having its own unique specification and requirements in terms of production resources. A job may consist of a single item or a batch of identical items. The scheduling problem here is concerned with the setting the sequence with which jobs should be processed at each production center. Of the various problems in batch production, we shall in this unit address ourselves to the problem of determining optimal batch size and aggregate production planning, disaggregation of aggregate plan to determine the master production schedule, and material requirement planning to achieve a given master production schedule, the problem of production control using the line of balance, that is LOB, in batch production, and some recent concept in batch and discrete part system. Next is features of batch production. Unlike mass production system, which tended to be organized as product layout with the machines or equipment arranged according to the product flow, batch production normally is done employing a process layout. Here, similar machines or equipment are grouped in departments, and different jobs will follow their own route depending on requirements. And apart from the greater flexibility afforded by the process layout as compared to product layout, and some of the advantages and disadvantages of process layout are summarized below. What are the advantages? Better utilization of machines is possible, consequently fewer machines are required. A high degree of flexibility exists vice versa equipment or manpower allocation for specific tasks. Comparatively low investment in machines is needed, and there is generally greater job satisfaction for the operator owing to the diversity of jobs handled. And specialized supervision is possible. Disadvantages: since longer and irregular flow lines result, material handling is more expensive. Production planning and control system are more involved. And total production time is usually longer, and comparatively large amount of in-process inventory result. Space and capital are tied up by work in process, and because of the diversity of jobs in specialized departments, higher grade of skill are required. In addition to these features, which are characteristic of the layout generally adopt in batch production, questions like what should be the size of the batch or how should various batches be sequenced arise typically. And although such a decision may be made in practice either in an ad hoc manner or by using certain rules of thumb derived from past experience, we demonstrate below a more rational outlook to arrive at the optimal decision pertaining to batch size. Next is how to determine the optimum batch size. Single product case. Let us consider a situation for the production of a single product on a machine under the following set of assumptions. There is a continuous demand for the popular means for the product R at rate D unit per year, and production rate for the product is P unit per year, and the setup cost per batch of size Q is fixed at A, that is independent of Q, and the unit variable cost of production is C per piece. So here is one figure, that is single product model with constant demand and no shortages. And inventory carrying cost per unit per year, that is H is equal to I. So C, where I is the annual inventory carrying cost rate, and no shortage are allowed. So figure 1 shows the change in inventory level with a cycle T. Okay, so please refer that figure. And here is a illustration with with the equations also. Okay, so please go through your ignou study material for this, so it will be more clear. And figure 2 is here, total annual cost as a function of batch size also. Okay, so equation also here, and the total annual cost equation 6.6 is plotted in figure 2. And example 6.1 is here, and please go through it. And multi product case. So what is multi product case? We shall consider a situation where n item are manufactured on a single machine with the restriction that there is common cycle time T for all the items. The n batches are thus phased with the common cycle. Assuming no shortages, the total annual cost for this multi-item case can be estimated as the sum of the total annual cost of each item independently. And extending the model for the single product case by including a subscript J for the jth product. So equation also here, and figure 3 is explaining production of multiple batches on a single machine with a common cycle. Please refer this figure and equation also here. And please refer mmpc 009 unit 6, and example 6.2 is here. Try to analyze this and solution also for the example solution also here. Okay, the purpose, the next one is aggregate production planning. And the purpose, customer demand enters the production system as unit of product. Aggregate production planning is concerned with developing the workforce and machine time allocation to meet a given demand schedule over the planning horizon. The purpose of this exercise is to produce at an aggregate plan in terms of the overall production of all products combined, such as production in tons of steel and or liters of paint, which would have to be disaggregated to yield individual product schedule. And when planning workforce and related activities to conform to a given demand schedule, and it is necessary to balance the cost of building and holding inventory against the cost of adjusting activity levels to fluctuations in demand. And here is figure 4 shows a hypothetical cumulative demand pattern and two alternative production strategies also here. So alternative 1 uses constant workforce level, and alternative 2 is a strategy to produce as per demand so that the inventory carrying costs are minimized. And these are two extreme alternatives. The optimal alternative is the one that minimizes the total cost of the inventory and the cost of adjusting the workforce level. And primary output of the aggregate planning process is a master schedule, which describes the number of units to be produced during each period and the workforce levels required by period. So here is one figure, and that is two alternative production schedule for meeting demand. Next is a brief review of the approaches. Perhaps the simplest approach to aggregate production planning is graphical, in which the cumulative demand is plotted as shown in figure and 5, and the alternative production plan, that is shown dotted lines, are compared in terms of their cost, and the most economical one is adopted. This approach suffers from the drawback that choose the best plan from the ones considered and not from all possible plan, which in fact could be infinitely large and difficult to conceive. And the above limitation is to some extent taken care of in mathematical optimization model. The approach for finding the optimal alternative in such a case is to develop a total cost function which contain the major cost components of the production facility. This cost function is to be minimized while subject to constraints. The linearity or non-linearity of the cost function and constraint determines the solution approach to the problem. The multi-period production planning model can be treated as network flow problem and solved by special procedures. And other methods for dealing with the aggregate production planning problem could be heuristic rule or computer search procedures. And a review of approach to aggregate production planning may be found in Buffer, Ilion, and Elsiade and Boscher. And disaggregation to a master schedule. The production facility considered example 3 is a chemical plant which is shared by product A and B, and simultaneous production is not possible. So therefore we should plan the production of each product by alternative the use of the facility between products. A disaggregation of example 3 requires the determination of the batch size of product A and B that will be produced each time a changeover occurs. And the necessity and desirability of disaggregation is situation dependent. Institution where product demand estimates are likely to differ from actual values, plan management may proceed to set hiring policies based on aggregate planned hours production requirements, with the assumption that forecast errors for individual products will be offset in the aggregate. And in situations where demand estimate are precise, it is reasonable to consider a complete disaggregation of their production plan to the individual product level. And when such a disaggregation is done, the resulting output is called a master schedule, a schedule of the time bound completion of production. So here is example is here, please read this example, and okay, it will more clear for you. And the next section is material requirement planning, that is MRP. Okay, all of you know what is MRP, right? Overview and problem definition. MRP is a system planning and scheduling the time phased material requirement for production operation. And by using the method of aggregate production planning and subsequent disaggregation, we can determine the weekly master schedule for end products and the requirements of sub assemblies, components and raw stock item related to those end products can be simply derived from the end product demand. Okay, and the manufacturing routing sheets and product bills of materials describe the departmental routing and production time to manufacture the sub assemblies and components. Using this database in conjunction with a schedule of end product requirement, and it is possible to compute the timing of production for each component to meet the given end product schedule. This is this in effect in the object of material requirement planning, that is MRP system. This given the master schedule of end or final product, MRP compute the timing of all the sub assembly, component and raw material production and purchasing activities required over the specified production horizon to meet the master schedule of the end product. Moreover, it does so in such a way as to attempt to minimize work in process inventory. And owing to the large amount of data storage, a typical batch production facility may purchase or produce 20,000 to 100,000 components. Retrieval and computational requirement practical MRP system have to be computerized. And MRP2, that is manufacturing resource planning. It is an integrated information system used to plan and control inventories and capacities in manufacturing companies. Manufacturing resource planning system coordinates sales, purchasing, manufacturing, finance, and engineering by adopting a focal production plan and by using one unified database to plan and update the activities in all the system. And explosion requirement. A particular product is generally composed of sub-assemblies and parts which in turn could be traced to item at the next level in the typical tree like a product structure. The problem of finding the demand of all components sub-assemblies for a given demand of the end product is referred to as part explosion. The problem could be complicated as a component or sub-assembly may be needed at a different level of the same or different end products. Okay, so suppose here is an example is here. Please read this from your ignou study material. That is mmpc 009 unit 6. So here is figures also. 2 and product 1 and 2 is here. So please refer this from your study material. And parts explosion diagram for end product 1 is here. So please go through it. And part explosion diagram end product 2 product structure tree is here. Okay, this is that tree of that. And again, these are the examples of all what we discussed above. Okay, so example 6.4 also here. Please go through it and the solution also with that. So MRP system in practice, the major advantage of MRP approach is its ability to plan discrete production for a very complex production system. MRP simply try to schedule all the activities required to meet a given master schedule while holding down work in process inventory. And many commercial available MRP software package provide a number of informative report as shown figure here is that the typical structure of an MRP based planning is here. Okay, so in core there is a software logic is here. So behind that all this. Okay, the major input to the system are the master production schedule specifying what to produce and when, and the product structure data including bill of material routing files with the manufacturing or procurement lead time, and the inventory status file for a raw material, work in process, and finished goods. And among the output from the package, the gross and net requirement report indicate the timing of orders releases required to meet the master schedule. The capacity versus load report is determined the whether resources required by the work center are available to produce these orders, which is useful in planning overtime or subcontracting. The shop floor planning report is a listing of jobs by due date, where the due date indicate when machining at the department should be complete in order to meet the schedule indicate by the gross and net requirement report. The shop floor supervisor will then release job to machines with the completion time in hours and due dates for the items. A typical commercial system provides additional information in the form of exception reports indicating jobs to be expedited or de-expedited as a consequence of delay in production of components. De-expediting holds down work in process inventory, and in fact an MRP system has to be tailor made to the need of the organization, though most of the above features along with the any special requirement are generally provided for. Okay, so this is about today's section. We will discuss next subsection on next video. And for more MBA videos, you just do like, share, and subscribe our channel. Thank you so much.
i-tutor Academy presents ignou MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 217 885.